Okay, hello. Sorry about that. That's weird. Whatever. Okay, so now we're gonna take some notes. So the last thing was an exploration for you to try to like get a little I don't know, head start on the material. And now we're actually gonna take notes. So you have like some concrete um stuff to go back to. So these are going to be derivative rules. We're going to review everything and also include the trig functions. Okay, so I'm just doing this on notebook paper. We have derivative rules, and then, whoops, that was ugly. Sorry. We're going to have integral rules. Yeah. Okay. Starting, so, and then we're gonna like split this into like 3 little sections. I'll do it later. Okay, so we're starting with polynomials. Okay, so first, remember if we have y equals ax to the n power, then when we take the derivative, our dy dx should be n times ax to the n minus 1. Okay, polynomials. We'll do a quick example. That was an ugly, I'm sorry, guys. This doesn't matter. At this point, I'm just wasting your time. I'm sorry. Example. And if we're given that y was equal to 3x to the 5th, we take our 5, multiply it by the 3. So our y prime should be 15, and then we subtract 1 from the original power, which was 5. We get x to the 4th. Okay. Move on to integrals. So on the right-hand side, you should have the integral of ax to the n power dx. And dx just means we're integrating with respect to x. That's the particular variable we're integrating. This should give us ax to the n plus 1. So we're adding a power because we're doing the opposite thing. We're dividing by n plus 1, and we have to add c on the end for some sort of constant that may have been there before. So for example, if we had the integral of 12x cubed dx, then we would get 3x to the 4th plus c. Add 1 to the power, 3 plus 1 is 4, and then we have to take that 12, divide it by our new power, which is 4. 12 divided by 4 is 3. Okay, that's polynomials. Hopefully that was very straightforward for you. Then we're going to move on to exponentials. Okay. So if you are given y equals e to the x, our dy dx should be equal to e to the x. All right. This only gets tricky when we have the chain rule, which I'll do an example of. Okay. So if I have y equals e to the 5x, that 5x can be differentiated. So our y prime is going to end up being e to the 5x times 5. Okay. And we would want to rewrite this as 5e to the 5x just because we like the coefficient being out front. Okay. And then when we integrate, our integral of e to the x with respect to x is always just e to the x, add on our constant at the end, and we're good to go. And then if I do an example, maybe I have 10e to the 5x dx. In this case, I need to use the chain rule. U substitution is the chain rule for integration. So u is going to be our 5x. Our u prime, or let's see, sorry. I'm using a previous teacher's notes, and she taught this a different way. Du is equal to 5 dx. Look here, we have 10 and we have dx, but we have 5 dx here. This means that we need to multiply this by something to get this 10 right here. So if we multiply this whole thing, oh, not by 10, 5 times what is 10 is the question we're asking ourselves. We should get 2. We might multiply that whole thing by 2. We should get that 2 du is equal to 10 dx. Now, this thing is exactly the same as the thing inside of my integral, and I can replace it. So I'm going to say that this is going to be the integral of e to the 5, whoa, I'm replacing with u, e to the u times 2 du. Okay, and you can rewrite that if you would like, so that the coefficient's up front, just because that's a little bit nicer. And when we integrate this, we get 2 e to the u plus c. Okay, sub our u back in to get 2 e to the 5x plus c. Final answer. Okay, and last but not least, we have our logarithms. Okay, so this is just review. So logarithms. Okay, so if we are given y equals the natural log of x, then our dy dx should be 1 over x. Okay, and we'll do an example. Y equals the natural log of 5x plus 6. So when we take the derivative of this, we just do 1 over the inside of the natural logarithm. And then we have to multiply by the derivative of the inside of the natural logarithm. The derivative of 5x plus 6 is just 5. So our final answer should be 5 over 5x plus 6. Okay? Oops. Let me hide this little guy so it's not in the way. There. Okay, there it is. All right, now integrating. If I'm integrating 1 over x, this is the tricky thing, okay? So if you messed up, you would look at this and you would say, oh, I could rewrite that as x to the negative first power. But when I have x to the negative first power and I add 1, negative 1 plus 1 is 0. That is your cue to say something's wrong. I can't just have x to the 0 power, okay? X to the 0 power is 1. And if I took the derivative of that, I don't end up with 1 over x, okay? So when I see 1 over x, if you make that mistake initially, that's fine. Just make sure that you recognize that that should integrate to natural log, okay? So you'll go here, you'll say, oh, x is negative 1. X to the negative 1 power is the same thing as 1 over x, but negative 1 plus 1 is 0. Can't do that. So this must be the natural log of x plus c. Okay, let's do an example. Okay, and remember that we learned these doing that exploration and graphing a bunch of different points. Yes, but that was a while ago. I'm not going to redo it in this moment. You can look back at your exploration. That was from before COVID-19. So you have it. Okay, so we have this. And we can rewrite this with the chain rule. So u is 4x plus 1. Du is then 4 dx. Okay, now I can replace my u. Okay, my u can go right here, but the stuff I need to replace my du with is 1 dx, but I have 4 dx right here, which means that I need to get this 4 to become a 1. So I'm going to multiply this whole thing by 1/4. So I get that 1/4 du is equal to dx. Now my 1 dx can be replaced by this guy right here, okay? That thing is equal to 1/4 du. Therefore, this should be the same thing as the integral of 1 over u times 1/4 du, okay? Remember the constants can just come out to the front. of the integral. And you know that the integral of 1 over u is just u, the natural log of u. So this is 1/4 times the natural log of u. Oh no! We need to sub our u back in. I come over here. So this is going to be 1/4 the natural log of 4x plus 1. Okay? And plus c, I'm sorry. And that would be your final answer. Okay? So that was your review. Now we're going to go through and we're going to do this for sine, for cosine, and for tangent. So let's flip our notebook paper. Also, these are already posted all on PowerSchool Learning, so you don't have to, what's it called? Freak out if this is too fast. Okay, so we're going to do the same thing. We have derivatives, we have integrals. Okay, we're going to have sine here, sine there. Okay, and then we're going to have y sine x. We figured out that our rule is that the derivative of sine is cosine of x. And then our example, okay, y equals 3 sine of 2x. So my dy dx should be 3 cosine of 2x, and then times 2. This times 2 comes from my chain rule that I did right here, okay? And then when I combine all of my like terms and my coefficients, I should get 6, whoops, sine of 2x. Okay, that should be my final answer. Let's do a quick integral with sine. So let's see here. We are integrating the sine of x with respect to x. We know that this should be negative. Ooh, that doesn't look like a negative. It looks like I extended my equal sign. Negative cosine of x plus c. Let's do an example. So the integral of 4 sine of 2x plus pi with respect to x is going to be my example. It's really ugly. Okay, so let's see here. We want to do the chain rule. So my u is going to be 2x plus pi. This means my du is going to be 2 dx. Notice that what is in my equation that's not u is 4 dx. I want that to be this. I want those two things to be equal. So I'm going to multiply this whole equation by 2. So I get that 2 du is equal to 4 dx. And so now these two things are exactly the same. And I've shown that that is exactly equal to 2 du. So I can rewrite this whole thing as the integral of 2 sine of u du. Okay, I just split up the 2 and the u, put the 2 in front of the sine and the du at the end. Now the integral of sine is negative cosine. So I'm going to have negative 2 cosine of u plus c. I need to put my u back in, so negative 2 cosine of 2x plus c. Okay, and that should be your final answer for sine. Okay, let's go ahead and do derivatives and integrals for cosine. I think my pen might be dying. I'll just go ahead and check that one. Start with a new one. Okay, so y is cosine of x. We know that dy